Okay, guys, so here's a video that is going to help you on figuring out what you can write down for Tuesday's periodic table formula chart summative. Remember, the whole point of this is just to get you to figure out what you can write down on Wednesday. So as soon as I say you may begin, I want you to rip out the perforated periodic table and formula chart and write as much stuff as you can think of down. So on this, you're going to get credit for anything that has to deal with science that you learned in middle school, even if it's not something that I came up with. If it helps you and it is something that you learned in middle school, I'm going to give you points for it. Of course, some things are going to be worth more points, like 8-man and all that other kind of stuff. So I'm actually going to start on the formula chart side first. So, of course, when it comes to the formulas, I want you to make a pyramid for all 4 formulas. Now, if the STAR test gives you the formula, then you know they're going to ask you a question on it. Now, even though this one is the only readiness TEK, which means you know it's going to be on the STAR test, pretty much you can bet that calculating speed will be on there as well, and more than likely integratable. So when it comes to the pyramids, the only thing that really matters is which variables go on top, okay? So the way that I remember it is my DFW, which is M, D, F, W. So my Dallas Fort Worth, right? Now, this means that for density, mass goes on top, which density and volume can go on the bottom. For speed, distance is on top, so speed and time can go on the bottom. The second one means force is on top, so there's mass and acceleration. And then the last one is work, so it is force and distance. Remember, to use the pyramid, you just simply cover the variable that you are looking for. If they are one on top of another, that means you divide. If they are beside each other, you multiply. Now, I know that it's not going to be hard math, but you do not get a calculator like you do on the math STAR test. So you are going to have to remember how to multiply and divide decimals. So these are the ones you do not want to be lazy on because you are going to have to do more work. So therefore, they're going to be worth more points. All right, so this is 20 points right here, 5 points for each pyramid. Okay, so let's go ahead and start with plate tectonics. Okay, so we know there are 3 types of boundaries. Okay, we have convergent, divergent, and transform. If you want to write them all out, that's fine. But again, as long as you know what you're talking about, that's all that really matters. And so you can go ahead and write the geological features underneath it. Like I know Kylie uses time or TIM, but without the E. So T for trench, I for island arc, and M for mountains. And then you can just go ahead and add the V for volcanoes. Divergent, remember when your parents get a divorce, they separate. It's really rough on the kids, which is rift zone and ridges. And then transform, it doesn't really make any geological features, but it does cause earthquakes. Okay? And I'm going to actually kind of squiggle around it so I don't get confused on what's what. So how about we also do the HR diagram? Okay, we know the HR diagram is probably going to be on there. You have that band that goes down the corner, and that is called the main sequence. And as you move from the left to the right, this is going to be your temperature. The stars actually cool off. So hot is going to be on the left and cool is going to be on the right. Now here's one that y'all tend to forget is luminosity, which is how bright it is. So actually, the higher you go up, the brighter the star. So the ones at the very top are bright, where the ones toward the bottom are dim. Okay, and then you have your dwarfs here, and you have your supergiants, and then your giants. Okay, let's go into topographic maps. Remember that topographic maps are maps that are used to measure elevation, and we show elevation with contour lines. So anytime you have another contour line, that means the elevation is changing, okay? So this is a contour line, and it shows elevation. So let's pretend that here is the peak of a mountain, all right? And I tell you that the peak is 450 feet, and that on point X, that is 100 feet. And you walk from point X straight to the peak of the mountain. What elevation do you walk? Well, you're just going to subtract it. So 450 minus 100 would be 350. Okay, so, and remember, the closer the lines are together, the steeper it is, the farther apart, the more gradual it is. We could also do our kinetic potential energy. Remember, if you have a ball and it's at rest, that is potential energy. Once that ball starts rolling down the hill, it turns into kinetic energy, which is energy in motion. Newton's laws. You have the first law, which is inertia. The second law, which is force equals mass times acceleration, which we have right here. And the third law, which is action-reaction. Now, one thing I want you to notice on Newton's second law, if your mass decreases, that means your acceleration is going to increase. If your acceleration decreases, that means your mass probably increased. So these two are always going to be opposite of each other as long as your force stays the same. On action and reaction, look for keywords like equal and opposite. If it shows things moving in the opposite direction, then that's most likely going to be action and reaction. So try to identify the forces in it. Let's see, what else could we talk about? Oh, also, if we're going to go ahead and finish off physics, we know that balanced forces is 0 newtons, and unbalanced force is any other number that's not 0. So it's anything but 0, okay? And we know that if there is any type of change, if there's anything but change, then it is an unbalanced force. Also, so speaking of balanced forces, when the two forces go in the same direction, you add them together. If they go in opposite directions, then you subtract. Okay? Let's do speed, velocity, and acceleration, the difference between them. Okay, remember that speed is distance and time. Again, we have a formula for it. Velocity is everything that speed is and add direction. And then acceleration is going to be a change in speed and or direction. So if I'm going the same speed, but I'm going around a hill, then that is accelerating because I'm changing my direction. So change is the key word on that. Kind of thinking, remember on the life cycle of a star that all stars do kind of begin in the nebula, and then the way that they change is based on their mass, but that'll kind of go with the HR diagram. The different types of galaxies, those are pretty easy for you to remember. Let's do the lunar cycle and seasons. Okay, the lunar cycle is something that's definitely going to be worth a bunch of points. Now, if you just want to write the 4 main phases, I'll give you 5 points. If you want to do the whole thing, I'll give you 10. Okay, remember when it comes to the lunar cycle, I always want you to start with the new moon, and remember to find the new moon, it's always going to be the one in between the sun and the earth. So once you have the new moon, then you're going to go counterclockwise. So if you just want to do the 4 and do like first quarter, full moon, and third quarter, you can go ahead and do that. And that would be worth 5 points. If you want to go ahead and do the others like waning crescent, waxing crescent, waxing gibbous, waning crescent, then I will give you the full 10 points. Remember, gibbous is where you're seeing most of, actually flip that around. Waning gibbous is where you're seeing most of the sun, and crescent is where you're only seeing a tiny little bit. Okay. All right, so to go into seasons and tides, remember that, let's go ahead and do tides because it kind of plays into the lunar cycle, that straight is a straight line is always going to equal a spring tide. So if I look at that, when they are in a straight line, that is a spring tide. When they are at a 90-degree angle, that is a neap tide. So on a spring tide, high tide is higher, low tide is lower, so it has a large tidal range. On a neap tide, high tide is lower, low tide is higher, so it has a very small tidal range. So this would be a neap tide. So first and third quarter are neap tides, new and full are spring tides. So seasons, if this is my sun, remember, and your earth is tilted, if you are tilted towards the sun, then you are in summer. If you're tilted away from the sun, then you are in winter. So towards is summer, away is winter. Okay, if the sun is tilted towards, that means summer is going to have more sunlight. So it has longer days, where winter has less sunlight, and therefore it has shorter days. Summer also gets direct type of light, where winter gets indirect. Also on the lunar cycle, you can remember to wax on, wane off, and waxing is the right thing to do. So waxing will be on the right side, where waning will be on the left side. Let's go into weather. So we know that if you have a big H, that is happy weather. And remember, happy weather is cool and sunny. A big L, because remember the star test isn't going to be color coded, is lousy weather, and that is going to be warm and rainy. Okay. Also, to go in with weather, a cold front has the spikes, where a warm front has the semicircles, and a stationary front is when they are on opposite sides. And you can always tell which way a front is moving because they're always going to be moving in the direction that the symbols are on, except for a stationary front because, again, It's stationary, so therefore it is not moving. All right, so now we need to get into some life science. Kingdoms was something that y'all struggled with, so really that one's just vocabulary. So that kind of goes into that pro, no, you do. And if you don't remember what that stands for, pro, no, you do. That should be a big D. What that means is prokaryotic cells do not have a nucleus, where eukaryotic cells do have a nucleus. Okay, so like you are eukaryotic cells, so you do have a nucleus. Also know that autotrophic, remember, those were organisms that make their own food. So autotrophic is the same thing as a producer. And so let's put makes food. Heterotrophic is the same thing as a consumer, which means it has to obtain food or energy, however you want to say it, because not everything eats. Talking about cells, you could list types of organelles, like know that the mitochondria gives you energy, that the chloroplast does photosynthesis, which is plants only, which kind of brings you into that autotrophic. What else? The nucleus is like the brain. The cell membrane protects. The cell wall helps to maintain shape. Any of those. If you want to go into body systems, we could do body systems. If you want to do a food chain, like you have to start with a producer to go to a primary consumer. And that we know that these arrows are showing the flow of energy. All right. We know that as you go from like one thing to another, that the energy decreases by 10% through the energy pyramid. I'm trying to think of what else in life science. We know that the way that humans hurt the ocean is pollution, the big garbage patch, fertilizer runoff. Ways that they help it is doing artificial coral reefs. Coral bleaching is because we are causing the temperatures of the ocean to rise, and it's bleaching out all the coral, which is therefore going to affect the entire ecosystem. I feel like y'all are good on energy, food chains, and stuff like that. I'm pretty good on genetics. Okay, so I'm going to flip over, but notice that you still have a ton of stuff. I mean, so like I said, 5, 10, 15, 20. This is 30. I mean, already you're at like an 80 looking on this side. So on the periodic table side is where I want most of our chemistry to go. Okay, first thing off the bat is go ahead and do Ape Man. This is going to be worth 30 points. Now, if you write Ape Man just like this, I'll give you 15. No, I'll give you 10. I'll give you 10 points. But if you actually want the full 30, you need to know that the A in Ape Man stands for atomic number, which is equal to the number of protons, which is equal to the number of electrons. Man is the mass number. Do not forget to round the mass number to the nearest whole number. Subtract it from the atomic number, and that will give you the number of neutrons. Okay? So, for example, if this is 14, then that means this is 14. So, therefore, the number of protons is 14, and the number of electrons is 14. Okay? They all will be equal. You take the mass number, which is 28, subtracted from 14, so the number of neutrons is 14. Speaking into the atom, somebody wanted to know if I had a cute way of remembering the parts, the subatomic particles. I don't, but you can just kind of go ahead and write them out. We know that protons are positive, that they're found in the nucleus, and they have a mass of 1 AMU. Neutrons are neutral. They're also found in the nucleus, and they also have a mass of 1 AMU. And then the electron, which is the oddball, he's negative. He is found in the electron cloud, and they have 0 mass. All right? Obviously, we need to ID your P. Now, if writing ID your P like this doesn't help you remember, then write protons, okay? But you just need to know that protons are how we identify an atom, okay? Dante's favorite, the 2, 8, 8, the electrons will appreciate. This tells you the level that go in each. So we have the 2, and then the 8, and then the 8. This is what it takes to make them full before you can go on to the next level. Because you get a pencil and a periodic table, you could go ahead and color code and highlight all your metalloids, which remember this big bold line, except for aluminum. And if I had a pencil, which I don't, but you can highlight all of your metalloids, and you need to create a key to help you remember. Leave all your metals blank, and then lightly shade all your nonmetals. So if, I had a pencil, I would lightly go through. You can still kind of tell it. Do not shade so dark that you kind of stop what you can read on the periodic table, because this is going to be your best friend when it comes into chemistry. And also, don't forget lonely old hydrogen over here, because he is also a nonmetal. All right, so we know that this number, okay, we know if you go up and down, this is called a group, and side to side is a period. The group number is always going to tell you the number of valence electrons. And I'm just going to write val E because I know what that means. So the group number always tells you the number of valence electrons. And if you circle the A is the one that tells you. Like 1A, group 1 has 1. If you look over here, group 14 has 4. Well, what do valence electrons do? Valence electrons determine reactivity. Okay, so just like protons determine our identity, valence electrons determine our reactivity. Okay, remember Ch is organic. If it has a carbon and a hydrogen, then it is organic. So this is group 18, and remember they are the unreactive group because they are the noble gases. And this is their favorite group to test on, is group 18. Every one of these has a full energy level. They all have 8 valence electrons except for helium that has 2. Now, it doesn't mean it's the only one that has 2 because there is still group 2. Group 17, remember these are the most reactive nonmetals. And then you have group 1, which is the most reactive metals. And remember that a period number tells us the number of energy levels. Okay. When you're talking about a chemical equation, remember to wrap, right? RAP, which is reactants, arrow, and products. So reactants are always going to go on the left. Products are always going to go on the right. Okay, so if you do have a chemical equation like 2H2 plus O3 yields 4H2O, Remember, what I want you to do is draw the line, list the elements, and then see if they're equal. So remember, if you have a coefficient and a subscript, we multiply the two together. So 2 times 2 is 4. This one's just 3. Over here, 4 times 2 is 8. 4 times 1 is 4. So is this chemical equation balanced? No, it is not. Okay, so that brings me into a chemical formula. I'm going to go over here and write a large chemical formula. This whole thing is a chemical formula. This whole thing is a chemical equation, so do not confuse the two. The large number in the front is called a coefficient, and it tells us the number of molecules or compounds. This little number is called a subscript, and it tells us the number of atoms. And remember, if you do not see a subscript or a coefficient, then it is always understood to be a 1, not a 0. And then we need to do chemical evidence, which is city girls love their phones. Okay. Color, gas, which is bubbles, light, temperature change, and precipitate, which is a solid. If any of these happen, then you know a chemical reaction has occurred. And when we say color change, it is an unexpected color change. Okay? I think that's everything that I can think of now. Make sure you understand the difference between a compound and an element. So if I wanted to put CHO2, this is a compound, where just O2 would be a element. Okay, so if it has more than one capital letter, it is going to be a compound. If it just has one capital letter, it is an element. And guys, I really think that's it. I mean, I know it's a lot, and I know I went really, really fast because I was trying not to make this video too long. I have complete faith in you guys. It's to that point now where it's out of my hands, it's in yours, and I know you're going to do the very best that you can. So just go home, study this. You will not get to use it tomorrow or Tuesday when I see you, but it's going to help y'all, all right? And I will see you Tuesday, hopefully. Good luck.